Hello everyone, this is Jyoti. Once again with another video that is on Inter-VLAN routing. So this video is in continuation with the last video on VLANs. So I posted a video on VLANs the last time that was on creating VLANs, how we can configure VLANs on a switch, what is the purpose of VLANs, configuration and verification of VLANs. So by VLANs, what we do is we can segregate or we can separate the broadcast domain of the switch into multiple different virtual networks by dividing the ports into different virtual LAN segments that are VLANs. So in that, what happens, the host belonging to the same VLAN can only communicate with each other and not between different VLANs. So now we are doing the opposite. If we need to make communication between different VLANs, then what is the method used? That is inter-VLAN routing. So we'll see here how inter-VLAN routing is configured. So first of all, inter-VLAN routing is a method of making communication possible between different VLANs without modifying VLAN or IP configuration. So in inter-VLAN routing, what we are doing is we are making communication between different VLANs, and different VLANs are nothing but small segments of a LAN, or you can say virtual networks only. And the process of making communication between different networks is routing only, that I explained in a video based on the basic routing concepts. So that's what we are doing here, the same thing we are doing here, but here the concept is of VLANs. We are making communication between VLANs, but if you see, these VLANs are different networks where we need to make communication. So routing is required for that. So this is done by encapsulation protocol. So the main protocol which is used here to provide communication between different VLANs is encapsulation, because along with routing here, one tag is required, that is of the VLANs, because here we are talking about different VLANs. So the packets that are going through the router or while routing should have the information of the VLANs. So for that, encapsulation protocols are used. There are two encapsulation protocols that can be used, that is ISL and IEEE 802.1q. ISL stands for Inter-Switch Link. ISL is a Cisco proprietary protocol, and IEEE 802.1q, or can be simply called .1q protocol, is an open standard protocol, IEEE protocol. ISL adds a 30 bytes of header, whereas IEEE 802.1q adds 4 bytes of header. This header we are talking about here is the tag. So as I said, the tag is added of the VLAN, that is called VLAN tagging. That is done by these protocols. ISL adds up 30 bytes of the tag, and whereas this .1q protocol adds 4 bytes of overhead only. So that's why .1q is a better protocol, first of all, because it's open standard, and also the header that it adds is not much of an overhead over the packets or the frames. So that's why you can see in the note as .1q is the commonly used encapsulation protocol. Next, we'll see the configuration. So the configuration of inter-VLAN routing can be done in two methods. First method is router on stick. The second is SVI, switch virtual interface. So the difference between these two is router on stick is used when layer 2 switch is there in the network. So if you have to enable routing between the VLANs that are configured on a layer 2 switch, then router on stick method is used. If you have a layer 3 switch, then we can use SVI method, that is switch virtual interface. In the router on stick method, router serves as the gateway. So to provide routing between different VLANs, a router is required as a gateway. Whereas in SVI, we do not require a router. So that saves a lot of cost also, because you do not need to add additional router, and also administrative work is less. So you can configure the routing on the layer 3 switch itself, because layer 3 switch is the switch that is being used in the network, and layer 3 switch has some features of layer 3 routing and IP configuration is supported. Then router on stick method has router as a gateway. So encapsulation .1q needs to be enabled on the router interfaces, because this protocol .1q or ISL, if we talk about, is a protocol of switches. So on switches, .1q is default enabled. ISL is not used anymore. So .1q is default enabled, but when we are using a router and we are using that for inter-VLAN routing, we have to enable this protocol manually on the router. In case of SVI, again, because it's done on the switch itself, so we do not need to enable encapsulation as it is default enabled on the interface. Next, you can see router on stick. So this is a screenshot of the lab that we are going to discuss and we are going to configure for router on stick. What we have done is we have a layer 2 switch here and we have two PCs connected. One PC is in VLAN 10, other PC is in VLAN 20. This switch is connected to a router. So we have connected a router here so that we can make communication between these two VLANs, that is VLAN 10 and 20. The configuration we'll see in packet tracer later. So here you can see the gateway is the router. We have two VLANs, VLAN 10 and 20 connected with the layer 2 switch. So we are using the method router on stick. This is the configuration of router on stick method. So we'll see this in packet tracer. So we'll not jump into this configuration or commands more. We'll just go directly in the packet tracer and do the configuration. I'll show you. So just in a brief, you can see we configure it on the interfaces of the router or the interface that is connected to the switch. On that interface, we have to configure encapsulation. So as there are two VLANs, you need to configure two sub interfaces. The reason is we are connecting the router by a single interface, of course, and that single interface is the physical interface. But we have two VLANs, so based on the number of VLANs, we have to create sub interfaces, and on each sub interface, we have to enable encapsulation. So by this encapsulation, what happens? The router is enabled to identify the VLAN traffic. Then we can see how trunk is enabled. If you have more than one switch, how you can enable trunking, that we will see also maybe in the next video. This is the next method, second method, that is SVI, switch virtual interface. This is also we are going to configure in packet tracer. So before that, you can see this is a screenshot of that lab that we are going to do. Here we have a multi-layer switch, layer 3 switch. Okay, there's typo. It's okay. So there is a gateway. The gateway is this layer 3 switch itself. Again, here we have two PCs. One PC is in VLAN 100 and the other one is in VLAN 200. So for SVI, we do not need any additional router because it's a layer 3 switch and it has the features of IP networking and routing, all that it can support layer 3 functionalities. So we can configure inter-VLAN routing on the layer 3 switch itself. And the configuration for SVI is this. On the layer 3 switch, we can configure out IP routing. So first of all, whenever you are configuring layer 3 features or layer 3 protocols, IP or routing, anything on a layer 3 switch, you have to enable this protocol, IP routing. By default, L3 functions are not enabled on a layer 3 switch, so you have to enable it manually by this command. So you just have to simply type this command, IP routing, and layer 3 functions are enabled on the switch. Then we create interface VLAN based on the VLAN number, give the IP address, that will be the gateway. Then same way for the other VLAN, interface VLAN 200 and give the IP address, which will be the gateway. So after this, you will see they'll be able to communicate to each other. So in both the cases, router on stick and SVI, we can verify by ping. The hosts that are in different VLANs and also in different networks will again be able to communicate by inter-VLAN routing. So this is how you can verify. You can do show VLAN and see there are these ports in different VLANs. We have different VLANs and you can ping between VLANs. You can also do show run to see your configuration on the interfaces. Now let's go ahead and do the configuration in packet tracer and we'll see how we can configure router on stick and SVI both. Okay, so let's get started with the configuration of inter-VLAN routing. We'll start with the router on stick method. So here you can see we have two PCs. So here I have labeled these with their IPs. 192.168.10.1 and 192.168.20.2 here. And these are in two different VLANs, VLAN 10 and 20. So we'll do the configuration from the scratch. So let's build this, and then we'll do the inter-VLAN routing. So first of all, let's assign IP 192.168 as mentioned on the screen, 10.1. Then, okay, so here we also require gateway because we need to configure inter-VLAN routing at the end. So let's take for VLAN 10, from the same network 10.0, we have to take a gateway. So we are taking 254 as the gateway IP. Same way on this PC, the IP to be configured 192.168.20.2 is the IP, and let's take gateway as 192.168.20.254. So IPs and gateways are configured on the PCs. Now let's go to the switch and do the configuration. So first we need VLANs. So what we'll do is we'll create VLANs, go to the configuration mode, and this VLAN configuration I also showed in the previous video of my of VLANs. So VLAN 10, let's say I'm just giving any random name ABC. Then I'm creating VLAN 20 and name XYZ. Okay, so VLANs I've created. Now I have to bind interfaces. So interface numbers are F02 and 3. So interface F02, switch port mode access, and this has to be in VLAN 10. So switch port access VLAN 10. Same way for interface 3, switch port mode access and switch port access VLAN 20. So I have created that. Now, also here I'll show you how you can configure trunk. So we discussed in the previous video and also in this video that trunk is configured. So we discussed also that the interface connecting the switch to the end devices or PCs have to be accessed. So that we made by the command switch port mode access. And the port connecting switch to switch or switch to a router must be trunk. So for that, we have to go to the interface F01 it is, which is connected to the router. And this should be trunk so that it can carry multiple VLAN traffic to the router. Okay, so switch port mode trunk is the command. And it will be done. Now, because we have two PCs connected on the same switch, but having two different networks and they are into different VLANs, so they will not be able to communicate to each other. Let's just give it a try, although we know it will not work. So 168.20.2, if I ping, I cannot ping. Okay, now we want this communication. We want to make communication between these two different VLANs or two different networks. So for that, because we have a layer 2 switch here, we need a router as a gateway. So let's get started with that. This is now inter-VLAN routing. So we have to first go to the interface, which is connected to the switch. Interface number is gigabit Ethernet 0 by 0. On this interface, physical interface, we do not need to configure any IP. We just have to enable it up. So just put no shutdown. No IP address is required here. We have to apply the IP on the sub interfaces. Why? Because it's a single interface, single physical interface, and to configure two default gateways on the single physical interface, we need to divide it into sub interfaces. So interface G0 by 0.10. This is how we configure sub interface. I have taken interface number 0 by 0.10 for VLAN 10. So this will serve as a gateway for VLAN 10. Now we discussed that in case of router on stick, we have to enable the encapsulation.1 queue, which is required so that the router will know the tags and will have the encapsulation.1 queue enabled, which is on the switch by default. Then configure the IP address, which is the gateway. So on the VLAN 10, we configured the gateway 192.168.10.254. Submit mask is 24. That's it. Then we exit and same way create another sub interface. So I'm giving it a number 20 so that it's more descriptive. And encapsulation.1q 20. This is in this command, and after your .1q you give the VLAN ID. Then IP address, which is the gateway. So in VLAN 20 the gateway was 192.168.20.254. 255.255.255.0, and it's done. This is how we configure inter-VLAN routing. So now we can just check. First of all, we can go to this and try ping. It will take some time, but then it will work, because for the first time it takes some time. Yeah, okay. You can see we can ping, although we are in a different network from 10.0 to 20.0 and two different VLANs, VLAN 10 and 20. Because of the inter-VLAN routing configuration done on the router, which is providing the gateway for both, so we are able to communicate here. This is how we configure router on stick. The other method is SVI, switch virtual interface, in which we have a layer 3 switch. So this method is used when you have a layer 3 switch. So you do not need a router additionally. Let me just correct this. And it's a switch. That's it. Okay, let's get started. Here the IPs we are taking is 100.0 and 200.0, and VLAN numbers 100 and 200. So the same way, just with this simple difference, we will just configure IPs first and then SVI. 192.168.100.1 is the IP. Then gateway, let's take 192.168.100.254. Let's go to the other PC and configure IP. IP as shown on the screen, 192.168.200.2 and gateway 192.168.200.254. So that's done. IPs are given. Obviously, we'll not be able to ping because they are in different VLANs and different network IDs also. So let's just give a try to show people who are new to this. Okay, we cannot ping. So now we want to make communication between these. Because we have a layer 3 switch, we can do this routing on the switch itself. So go to the CLI and configure SVI. First of all, to enable layer 3 functions, we need to configure IP routing. So we have to make routing between VLANs. So let's first configure these VLANs, VLAN 100, name ABC, same, VLAN 200, name XYZ. That's it. VLANs are created. You can also verify in both cases by show VLAN if your VLANs are created. Next, we have to bind interfaces to that. So you can see here, I just did that. We have VLAN 100 and 200 created. Now next we have to bind the interfaces. So in the configuration mode, go to the interface F01, switch port mode access, and switch port access VLAN 100. Same way for interface F02, switch port mode access and switch port access VLAN 200. So VLANs are configured, you can see, and the interfaces are there, right? Next, we need to do inter-VLAN routing. So as I said, on the switch layer 3 switch, we have to enable routing functions via command IP routing. You have to type for it. So by this command, the L3 functions will be enabled. Now we can do the inter-VLAN routing. So interface VLAN 100. We are not taking a router here, so we are creating virtual interface as the VLAN number itself. And encapsulation.1q in SVI is not required because it's a switch and it will be default enabled. Just have to enable IP address, which is the gateway 192.168.100.254, with the subnet mask 255.255.255.0, and for interface VLAN 200, same way, IP address 192.168.200.254.255.255.255.0, and that's it. After this, we should be able to ping. Let's just verify again, show VLAN, and yes, we have VLANs there, and we have interfaces in those VLANs. Now let's just try ping, and we should be able to ping. So if I ping now, so let's see if it can ping. And yes, we can ping this time because we have done Inter-VLAN Routing SVI. So here we discussed about router and stick and SVI methods to configure Inter-VLAN Routing configuration. I hope you liked the video and the video will be beneficial for you. It helps you, and thank you so much for watching.